Hello and welcome. I am Mr. Murphy, and in this video we're going to be looking at skill number 19, which deals with the compound interest formula and applying it to investment growth. So let's go ahead and let's first talk about what this idea of the compound interest formula is all about. Now, you're familiar with possibly just regular simple interest, which is we take a principal times your rate times your time. But that's not really very applicable to most real life situations. We have, in the real world, we have this idea of compound interest. And compound interest, what that means is that you're taking your interest rate and dividing it up through the year, as opposed to having the interest maybe accumulate throughout the year and then applying it at the end of the year. There are times where that might happen, but a lot of times, like for example, dealing with a credit card or dealing with a savings account, that interest is going to be broken apart monthly. It doesn't mean that you get the full interest every month. What that means is, like, let's say if you're dealing with a situation, let's just keep it simple. Let's say if you have a situation where you have 12% interest, that would be an annual interest rate. If it was compounded monthly, that doesn't mean you get 12% every month. It means that 12% gets broken apart over the course of those 12 months. That means every month you'd be getting 1% of your interest put back into your account. So you're gaining interest on top of your interest as the year goes on. So you can see that there's going to be some benefit to that. So the compound interest formula is given to us here. It's the principal times 1 plus your r divided by n. We'll talk about what these different pieces are in a second. And you're going to have an exponent that's going to be n times t. So what are all these individual pieces? Well, like I said, the P represents your principal. That's going to be the amount of your investment. So that's going to be your dollar amount. So anytime in your story problem, if you see the dollars being given to you and that's going to be the amount that you're investing, that's your principal. Now the rate, they're going to give you that as a percent. We don't do anything with percents. You can't do anything with the percent. You need to change the percent to a working number, which is going to be as a decimal. You can do that by dividing by 100 or simply by moving the decimal to the left 2 places. So you need to make sure you change that rate to from a percent to a decimal. The time, we always want to make sure that we're using our time value in years. So most of the time they're going to say that, how much you're going to have in the account 5 years from now or 12 years from now. But if they do give you a situation for how much is going to be in the account in 18 months, if you use 18 in your equation, that's going to be representative of 18 years. You want to make sure that you change it to years. So 18 months would be 1.5 years. We use 1.5 in that scenario. And then lastly, that n represents the number of times that it's compounded. Now there's going to be, they might use some phrases like it's compounded annually or compounded monthly or compounded quarterly. So we need to make sure that we understand what do those different phrases mean. So that's what this next piece is going to be about. So you can see that these are some common terms that we would use. So annually just means that it's going to be compounded once a year at the end of the year. So n, our value for n would be 1. If they use a phrase semi-annually, the semi means twice, so it'd be twice a year. So n would be 2 in that situation. Quarterly, well, if you think about it, there's 4 quarters in a dollar. So quarterly would be 4, so it's going to be 4 times throughout the year that interest is broken apart. Monthly, we talked about that already. Monthly, if it's compounded monthly, we're going to use 12 for our value for n. And there are some situations where the story problem will use the fact that it's compounded daily. So you can count on using 365 unless they make an exception. Sometimes they'll say to use 360, but obviously the default will be 365 unless they say otherwise if it's compounded daily. So let's look at an actual story problem now so you can see how we're going to apply this formula. So this particular story problem says Malik has $10,000 to invest in an account that pays 3.2% compounded quarterly. How much will be in his account after 8 years? So let's start by plugging in our information into the formula. So again, the amount that we're looking for is going to be your principal. Our principal in this case is going to be $10,000. So it's going to be 10,000 times 1 plus our rate. Again, our rate, even though, now some people get confused because here there's a decimal, 3.2%, but it's still a percent. We still need to change this by dividing by 100 or moving the decimal place 2 places to get it to a decimal. So we 0.032. We're going to divide that by the number of times it's being compounded. It's being compounded quarterly. So that means n is going to be 4. Our exponent is going to be 4, the number of times it's compounded, times the number of years, which would be 8. So now if you type this in on your calculator, 10,000 times 1 plus 0.032 divided by 4, and then you can use an exponent of 32 just to make it a little easier. When you do that on your calculator, you get $12,904.38. And that would be your answer. Now sometimes they'll ask, how much in interest did they make over the 8 years? You always want to make sure that you read the question carefully. If they ask how much interest they made, you'd want to subtract from our answer the original investment amount. So in this case here, he made basically a little over $2,900 over the course of the 8 years. But if they ask how much total, which is what they're asking for here, how much would be in the account after 8 years, this would be our answer. So it's pretty simple as long as you use that formula. So I want you to use the formula again for this particular problem. For Jessica, who is investing $8,000 in an account that pays 4.5% interest compounded monthly, how much will she have after 12 years? So I want you to work this out on your own. So go ahead and pause the video and hit play when you're ready to check your answer. Okay, let's see what you did here. You should have started by putting it into our formula. So it's going to be your principal this time would be $8,000 times 1 plus your rate. Your rate would be 0.045. It's compounded monthly, so you should have used 12 for a value for n. Just so happened that our time is also 12, so we'd have 12 times 12 as your exponent, or 144. And when you do that on your calculator, you should have gotten an amount of $13,714.20. That should have been your answer. Well, there you have it. That's skill number 19. That's how we use a compound interest formula to figure out investment growth. So hopefully you have a better understanding now of how to do skill number 19, and good luck on your quiz.